me 1 minute because
Okay, perfect. Uh, Hello, good evening. Welcome everybody. We have these Wednesday webinars every Wednesday. These are organized by Pune River Revival. Pune River Revival, or we can also call it as PRR. It is a group of many organizations, experts, concerned citizens who have come together for mainly rights of rivers. So through these webinars, we try to reach out to as many people as we can. And through these webinars and discussions, we learn more about rivers and trees and biodiversity, weather, all of that, all the related things. So that's why today we have Aditi Deshpande with us. Aditi is an assistant professor in the Department of Atmospheric and Space Sciences in Savitribai Phule, Pune University. And I think she can tell more about her area of research. And then you can little bit tell about yourself, Aditi, and then we can go ahead with today's webinar. Okay? Okay, thank you.
okay. So thank you everyone, and thank you to Pune River Revival for inviting me to give a talk. I have followed your work on social media for a while, and even the Ecological Society of India. I have tremendous respect for all of you who are doing so much to ensure that our environment is protected and there is, you know, it's kept pristine and not ravaged in the name of development. So I am originally from Mumbai. I did my schooling over there, and I've been in Pune since my MTech years, roughly around, it's been close to 16, 17 years. And I primarily teach basics of weather and climate. We have two courses, MSc and MTech, in our department. We primarily teach the physics of weather and climate systems, and I teach the basic subjects as well as oceanography, which is my subject of expertise. So my research primarily focuses on some large scale components and large scale circulation patterns of Indian summer monsoon and ocean circulation, and how changes in that is affecting our climate, and how climate change is also affecting these systems. So there's a vice versa sort of interactions that happen. So you let me know when we can start the talk if you want.
Yes, please go ahead.
Okay.
Yeah.
Okay, so the reason I decided to talk about Indian summer monsoon, or rather, I chose this topic is because this is something which is very strongly attached to almost every person who lives in the subcontinent, because the summer monsoon is one of the most unique systems that we see in the across the entire global system, and that is primarily because the Indian landmass or the Indian subcontinent that we see, it is to the north of the equator. It is the only ocean which has a landmass to the north, and this unique situation creates the monsoon system. And the monsoon system over the Indian region, or rather the Indian subcontinent, is one of the strongest across the entire world. But as we know that it's very difficult to actually understand how monsoon varies, how it changes, and it has, of course, a lot of impact on how the environment around us gets shaped because of changes in the monsoon. So to begin with, actually, I wanted to show this sort of a kind of a mood board that I do every time I start with teaching Indian summer monsoon. And every year I ask my students that, if someone just says the word monsoon, what comes to your mind? And usually you will see that they will come up with, initially they will come up with something like, hang on, I'm just trying to see the is everyone able to see my cursor?
Yes.
Yeah, I will use this laser pointer. Okay. So they come up with things like atmospheric parameters, seasonal change in wind direction. But when you tell them that, you don't have to really talk about science, but anything that you associate with monsoon. And then come these answers like puddles and umbrellas and warm tea and rain days, which were essentially, at least in my childhood days, when it used to rain so much that the schools would be closed, and now they are getting more frequent. But there are also now these terms which are becoming more common, like flu season, floods, and this was from the class of 2024. So I'm talking about around January, February of 2024. Unfortunately, this year, when I asked them, which was in 2025 of June, July, August, I asked them what they associate with Indian summer monsoon. The first three words that came up were floods, destruction, and damage. So it made me so disturbed that I actually forgot to take a photo. Usually I take a photo every year, but it was such a jarring experience for me that our association with monsoon, and we have a huge history of literature dedicated to monsoon. We have a cultural connection to monsoon, but now even that connection is changing. We don't look at monsoon as a life-giving system, because for the longest time, even when we are taught about monsoon, it is talked about as a life-giving system, but it's no longer considered as that. And this is actually one of the strongest changes and jarring changes that I have seen, not only in the system, but also in the way students or the youngsters are associating with it. So I wanted to keep the talk pretty simple and straightforward, full of basics. So I wanted to talk about what exactly it means, monsoon, the term monsoon means. First of all, it comes from a word Mausam, which is an Arabic term. So this being the most prominent system of the entire year over the Indian subcontinent, the monsoon word was derived from that Arabic term. And it is not just composed of rainfall. So we think of monsoon as associated with rainfall, but there are multiple systems which are existent. So all of these, which are written one after the other, I'll go through them in a bit. They are all systems which need to be in place for it to start raining over the entire Indian subcontinent. And like we know, it's not that we have summer season till 31st May, and then 1st June it starts raining everywhere. That is not how monsoon arrives in the country. There is a certain transition. So there is a little bit there are a few thunderstorms in some parts of the country. There are also some changes, some drop in temperature, the cloudiness increases. So all of these features are important for monsoon to occur over the system. And one of the most important systems, why it is called as a monsoon system rather than just rain, is because of the wind structure. So if we are to look at how winds appear across the Indian subcontinent and over the Indian Ocean, which is also a very important part of why monsoon exists in the first place, you will see that there are differences. So in December, January, February, which is also another monsoon system, although it's very weak, much weaker compared to JJS, you see that winds are sort of coming from northeast direction, and then they are turning just below the equator. In April, May, it's very difficult to actually give a specific direction except over the equatorial region, and same thing applies for October, November. But if you look at June, July, August, September, which is what we write as JJS, you will see this immensely strong wind structure that is entering the Indian subcontinent. And this is essentially data which is plotted only over ocean region, which is why we don't have arrows over the land mass. But if we were to plot it, you will see that the winds actually uh, move into the Indian landmass also. So some of the terms like the monsoon trough, the mascarene high, cross equatorial low level jet are actually seen over all of these systems. So mascarene high is essentially a high pressure system that gets created to the south of the equator. That is primarily because this is where the equator sits. If it is summer in the northern hemisphere, it is winter in the southern hemisphere. So temperatures in the southern hemisphere are going to be on the cooler side. And because it is hotter over the northern hemisphere, and the difference is that land heats up much faster and much more strongly compared to the ocean. Oceans have take a longer time period to heat up to a significant amount. So that is why there is like this temperature difference which is created between land and ocean, and that is what drives this entire wind structure. So this, what we are seeing, these extremely strong arrows of winds, that is the Findlater jet or cross equatorial jet as it is known. So the monsoon is not just combined of rainfall, it is also combined, or rather, monsoon is brought to the Indian subcontinent through these wind structures. So these winds carry a lot of moisture, and once they reach the coast, which is the initial stage, it reaches the coast of Kerala. So that is when the IMD usually declares that there has been onset over Kerala, and then it sort of progresses across the entire subcontinent, and you will see that there is another branch which also enters the subcontinent from the Bay of Bengal side. So this is the wind structure. So monsoon is not just rainfall but also wind structure, and there are multiple factors which affect the changes that are occurring in the monsoon. So when we think of the 4 months of June to September, we don't see the same amount of rainfall every year. So the amount of rainfall that it will rain on 15th July, let's say 2024, is not going to be exactly the same on 15th July 2025. And it was certainly not the same on, say, 15th July 1925. There is always a difference. So no 2 years of monsoon are the same. There is always a change from one year to the other. In addition to that, we don't get rainfall for 120 days of the 4 months 24/7. There are some days when there is a lot of rainfall, there are some days when it will only drizzle, there are some days when there is absolutely no rainfall and it feels like summertime heat because there are no clouds in the sky either. So these are different changes that happen in the monsoon system. And before we go there, I'm just showing this is the region where the monsoon trough forms. So these are all different systems which are considered to be associated with monsoon. So there is something called as mid-tropospheric cyclones. There is something called as onset vortex. There are something called as monsoon depression, which brings rainfall to regions which are not falling, which brings rainfall to certain regions under its influence. So the rainfall which we associate as the rainy season is not just because of one thing. It is because of multiple things of different sizes. So if you look at the monsoon trough, it's a very large scale system. It happens because of the low pressure that forms across the entire Indian landmass. The mid-tropospheric cyclones usually bring rainfall to the northwestern region where there is very little rainfall usually available. The onset vortex formation is essential to sort of bring these, or rather pull these winds moving from the across the equator towards the Indian landmass. So these are different systems, and they all have changes embedded within them. So again, every year you will not see the same number or same frequency or same intensity of mid tropospheric cyclones. Every year we will not see the same number, or the location where these monsoon depression forms will also not be the same. So every year there is a different monsoon, and this is one of the reasons why it is so difficult to sort of forecast it perfectly as to what is going to happen, what day, what hour it will rain. We can give forecasts up to a certain time period, let's say for the next 3 days or 5 days, or and there are also, of course, monthly means given. There are also seasonal forecasts which are given. So we sort of have an idea of how the monsoon will behave overall. But because these are different types of systems of different scales, and they vary on different time scales by themselves, and get affected by different factors, um, the whole rainfall or the monsoon system that we see is not something which is straightforward. It's a very complex non-linear system. So to bring out something which I spoke about, that we don't get rainfall throughout the 4 months of monsoon. So they are divided into what is called as an active spell and break spell. And this actually will give us a very good idea of how monsoon, even within the country, is not same. So if we take an active spell, which is when most of the country across the entire subcontinent gets rainfall, but you will see that there are these patches in the northeast and across the northern regions of the country where there is not enough rainfall when there is rainfall over the rest of the country. And as opposed to that, when we have very little rainfall over the mainland, the northeastern region gets a lot of rainfall. So this toggle of different areas getting different amount of rainfall is also a very complex nonlinear system, which is again one of the reasons why we cannot say that, oh, because it's raining in one location, it's going to be raining across the entire country. Monsoon progresses from Kerala all the way to the northern tip of the country, and the established phase has these phases where sometimes there will be very little rainfall, sometimes there will be a lot of rainfall, and that is termed as active and break phase or active and break spell of the monsoon. Now, the other thing which happens is the difference from one year to the other. So this is a time series which is maintained on by Dr. Roxy at Indian Institute of Tropical Meteorology, and it shows rainfall which is averaged over the entire country for all the 4 months from one year to the next. So you can see that not every year do we get same rainfall. There are some years when you have above normal, some years when you have below normal. This was a very significant drought. I believe this is 1877. Then this is another drought, and these are the, so 2010 was another really bad year, but 1960 was a very good year. So this tells us that there is sort of like a oscillation, seesaw effect, that some years we have good monsoon, some year we have a bad monsoon. So if we were to think about all the factors that affect the monsoon rainfall, the primary thing which is also currently in news is what is called as the El Nino. So El Nino is essentially a system which occurs in the Pacific Ocean. And it's important to note that although it's happening somewhere else, the Pacific Ocean, especially the equatorial Pacific Ocean, is the largest on the planet. So whatever happens in the Pacific has a signature on every part of the world. So what happens is, essentially, this is actually how the Pacific Ocean looks like in 3D. There is a lot of cool water along the coast of South American continent, and there is a lot of clouding and convection on the West Pacific side. Now, during El Nino, because of certain changes occurring in both the atmosphere and the ocean, what happens is this center of convection moves towards the central part of the Pacific, or sometimes even to the eastern part of the Pacific. And this has impacts on what is happening over the Indian subcontinent as well. So there will be changes in vertical wind structure over this area. There will be changes over the Indian Ocean region. You can see that the temperatures over the Indian Ocean are already showing warmer than average, but during La Nina, which is the opposite of El Nino, we see slightly cooler patterns. So everything, just like the Indian Ocean, has an impact on how strong or how good the monsoon will be. So does the Pacific Ocean. And this is another sort of a schematic which shows exactly how many parts of the world it actually has an impact on. So it is not that El Nino just affects Indian summer monsoon. It has effects all over the world. Like there are changes happening on over the South American continent. There are changes happening over Australia, Africa, large scale Asian system, as well as over the Australian system. So as the seasons change, the phase of, or the manner in which El Nino and La Nina is evolving will have an impact across the entire world. So we can literally see that it is something which affects everything in the weather system. The other system which has an impact, which actually occurs in the Indian Ocean itself, is something called as an Indian Ocean dipole. So there is actually a very interesting story about this. If we go back to this system and we look at something like 1997, yeah, somewhere around here it should be, yeah. So 1997 was a year when there was a forecast of very strong El Nino. It was actually the strongest El Nino of the century. And because we usually associate less than normal rainfall or a bad rainfall with El Nino, so you will see that if you look at the dots, most of the years when we have below normal or bad rainfall are the years when there is an El Nino. So considering that it was the strongest El Nino of the century, it was assumed or it was understood that it would be a really, really bad monsoon. Or we would not understand, we didn't have a clear enough forecast on exactly how bad the situation would be. Turns out that in 1997, rainfall was slightly above normal. It wasn't actually a bad year at all. And that got a lot of scientists to wonder that whether El Nino actually has an effect on Indian summer monsoon rainfall, or is that relationship changing. So that is also one more thing, that in addition to changes or variability within the season and changes from one year to the other, there is also a long term change. So some decades you may see a very strong impact of El Nino on the monsoon, some decades we may not. And this was one of the years that triggered the curiosity of the scientists. And then they found that turns out that there is a system which occurs over the Indian Ocean itself, where there is a lot of cold water coming to the surface of the ocean, just off the coast of Java, Sumatra, and this region of the coast of Africa gets a lot of warm water. This they labeled as positive Indian Ocean dipole. And the year when the 1997, when it was a very strong El Nino, there was also an IOD forming, positive IOD forming in the Indian Ocean. And this, when there is a positive IOD in the Indian Ocean, we are known to have near normal or slightly above normal rainfall. This is a negative phase of the same system. So, a system has a positive phase and a negative phase, which is the opposite of each other. So this was the reason why we did not, this was one of the reasons why we did not have a very really bad drought. But in addition to this, there is also the influence of Atlantic Ocean. There is the influence of the amount of snowfall that occurs over Siberian region. There are multiple factors across the world, including changes that are happening in the Antarctic, changes in the currents which are happening over the Indian Ocean. All of them have an impact on the monsoon system. And of course, the monsoon system also has an impact on other systems, but because rainfall, the monsoon system is so important for us, we need to pay, we tend to pay attention to all of these systems. So, in addition to this, this is a recent work which we've submitted for publication. We tried to look at what exactly is changing in monsoon. So nowadays we hear of flooding and flash floods on a very regular basis. And as a result, we need to see exactly what is changing. Is it that, it's also become a thing that anytime we see something which is unexpected, we blame it on climate change. While climate change is a very important and a strong factor affecting systems, it is not always the answer. So this is actually a mean picture of what rainfall looks like. So we get most rainfall over the Western Ghats. We get a lot of rainfall over the northeastern states. And then the other region which gets a lot of rainfall from summer monsoon is the central Indian region. What we did is we looked at the time period from 61 to 89 and then 1990 to 2018. And then we just subtracted the average of 1990 to 2018 minus 61 to 89. So there were two averages, one minus the other. And then we saw that there are these regions which seem to be going through a lot of changes. And you can see that the one of the regions, which is the Thar and Kutch area, seems to be having more rainfall than normal, whereas the Indo-Gangetic plains are becoming drier and the Northeast is also becoming drier. What does this mean? Does this mean that they will never see floods, or that Thar and Kutch region will now start seeing floods? That is not necessary. It basically means that the average rainfall that the region receives over the 4 months is either increasing in some regions or decreasing in some regions. So some areas which are sort of used to having lesser water will now have more amount of water available. But some other areas where there is ample water available may have regions which start going dry. And this is another publication which we came up with in 2025. We looked at how much mean rainfall is changing and how much is the change in extreme events. So extreme events are defined as anything which surpasses here we have taken the level as greater than 150 mm, and you can see that the same region which we saw in the previous slide, the Indo-Gangetic plain seemed to be getting less rainfall, and the northeast region seems to be getting less rainfall. But then there are these regions like the Gujarat region, the Maharashtrian uh, coastal region, which seems to be getting more and more rainfall. But not only is it getting more mean rainfall, it is also getting a lot of rainfall from extreme events. So extreme events is when you get a significantly higher amount of rainfall over a very short period of time. And you can see that they are also increasing over the Gujarat coast, but not so much along the northeastern coast. So studies like these actually highlight areas which are becoming more and more vulnerable. So an area which is not used to having a lot of rainfall. I'll give you the example of the Marathwada flood in 2025, a region which is historically known to be drought prone had so much rainfall that there were extremely intense level of flash floods in 2025, and that too this was during the withdrawal phase. So when what we call in Marathi as परतीच्या पावसाच्या वेळेला this flood happened. So the main aim of the two studies was to highlight which areas are becoming more and more vulnerable. What is happening is, if we take a general picture, we can see that mean rainfall is reducing, but there is an increase in extreme precipitation events. And this is becoming a problem because mean rainfall is important for agriculture, for water storage, for groundwater recharge, whereas extreme events tend to sort of wash off the uppermost layer of the soil. And then what happens is whatever crops have been planted, they get washed away. And then with that, the top layer of the soil goes off, which is nutrient rich. So you can't even start with new crop cycle. It results in what is called as Ola Dushkal in Marathi again. So this is something which we are seeing in the recent trends in the rainfall. In fact, there was also another study which talked about how the river of the Ganges is basically rejuvenated with groundwater recharge more than anything else. And groundwater recharge to take place, the consistent seasonal rainfall is a very important factor. So these changes in rainfall not only have impact on, let's say, flooding or water storage, but they also have an impact on the rivers and the kind of how much water the rivers can store, whether the rivers are going to break their banks. All of these systems come into place. So with this publication, we did one schematic of the regions which are becoming more and more vulnerable, and the publication story was covered in a paper called Pudhari, who were kind enough to put this out in Marathi, and we can see that there is a increase in heat stress and decline in mean JJS rainfall. So what does this suggest? If we have uh, persistent heat waves during the summer season or during the pre-monsoon season, as it is called, and then there is less rainfall, what this does is that it doesn't relieve the region of the amount of heat stress that it has suffered. This applies to everything from all living organisms, trees, human beings, the soil of that region, and multiple such things. So this is what is called as a compound event. So compound event is something where you have two very severe systems occurring one after the other, which create additional stress on the environment of that region. So already heat stress will also create some level of water stress, because water is needed in during very hot days. And then if there is not enough rainfall, then that puts additional stress on the people who are living in the region, also on the flora and fauna of that region. So this is now becoming more and more serious. The changes which are happening across the entire region. Uh, this is for Maharashtra. This was created by one of my co-authors, Dr. Roxy, and he looked at what is happening across the Maharashtra region. So if we looked at the rainfall trends, we see that along the Western Ghats, along the coastline, a lot of rainfall is increasing, but Madhya Maharashtra is not receiving that much. The trend over Madhya Maharashtra is not that high. But on the eastern side, again, there is an increasing trend. And unfortunately, there is also, if we take an average, we will see that there is a decline also in overall rainfall. So extreme rainfall, which will end up sort of washing off the agricultural crops, soil, and everything are now increasing, unfortunately. And areas which consistent rainfall is now decreasing. Also, the patterns, the areas where traditionally rainfall is supposed to happen, that those patterns are also changing. And what is happening along the coastline is that now, because Arabian Sea is warming much more significantly, we are seeing more and more cyclones along the coastline. There is also a lot of decline in the fisheries, because overfishing has resulted in a lot of decline. So how do we look at this? One of the reasons, one of the things that is utmost important is to map vulnerability. We have to figure out what kind of stress a particular community is going to experience in order to be able to help them. If we don't know what stress they are going through, we will sort of take a one size fits all solution, and that may not work for different areas. So we saw that even within the country, even if we say that monsoon is exactly the way it was supposed to be, some regions are prone to getting less rainfall, some regions are prone to getting more rainfall. Just taking one solution and trying to fit it to everyone is not going to help. So this is where the regionally tailored adaptation plans are important, that we have to focus on what that particular region needs. And this is not just across the entire country, but also on a state wise level, also on a district scale level. And we have to focus on what is happening to the compound events along with the extreme events. So there's a lot of attention given to extreme events, but now compound events are also starting to get very frequent. And of course, not everyone bears the brunt of any disaster equally. I always explain to my students that, when there is a flood in a city like Pune, what happens is, people like us, who are, let's say, going to the university or in jobs, we either get to work from home, students get an off day, and at the most we face trouble getting from our home to work and back. But communities which are entirely dependent, who are socio-economically marginalized, they literally have their entire lives washed out with the rainfall, and they literally have to start from scratch. So this occurrence on multiple times, or year after year, makes them even more vulnerable. And this is where uh, the changes that are happening to our system cannot be looked at just a science problem. It is actually a social justice problem. And as a result, we have to look at it as an important thing is to put planet over profit. Profit will have importance only for a handful few people, but the planet is for everyone. So this is what we need to do. So this was my talk, and I think I'll stop sharing, and then we can talk to each other.
Thank you, Aditi. We got to learn a lot, and I see one interesting comment here. We are in ENSO neutral right now. Can you
Yeah,
explain that? And one more, NOAA is predicting El Nino summer
yeah,
and winter.
yeah. So ENSO means El Nino Southern Oscillation. El Nino Southern Oscillation has two components. So El Nino is the component of what happens over the sea surface temperature in the Pacific Ocean, and Southern Oscillation is a sort of a seesaw oscillation that happens of sea level pressure over the near the equatorial Pacific itself. So neutral in the sense that it is not showing any kind of changes. It is not showing any signal of an El Nino taking place. So what happens is certain years. So El Nino has a periodicity, or rather used to have a periodicity of 2 to 7 years. What used to happen is sometime between every 2 to 7 years, the East Pacific region along the coast of South America would start warming up, and that is what I showed you, that the warm water which is over the Pacific starts cooling. Well, it doesn't cool down, but then the difference in east-west temperatures become less. So that is the positive phase of El Nino. Now, while we are in a neutral phase, all the models, all the climate models are saying that it will turn into an El Nino. Like El Nino is, again, no system on the planet is like a switch. म्हणजे yesterday uh, there is no El Nino. Tomorrow it is full blown El Nino. It is still in the evolving stage. So we are actually already seeing changes which are indicating that there will be an El Nino in the summer and winter. So summer as in sometime around June, July, August, September. And winter is when it peaks, the intensity of the El Nino peaks, which is in December, January, February. So, yeah, that is what is happening. And NOAA is essentially National Ocean Atmosphere Administration. So it's a sort of a sister institute of NASA who looks after all the climate and weather systems.
You can read the next
Yeah,
question and then answer so that
sure,
everybody
sure.
knows what the question is.
Yeah. Uh, Okay, so this is by Damini Mahajan. It's an interesting question, but see, it's a mixture. So I'll just read out for those who may not have been looking at it. My uncle is not an environmentalist and he doesn't read newspaper also. He says that El Nino, La Nina is not originated from India. So other countries should take responsibility for it. They should do something to mitigate the climate change. How can I explain India's role to him? Okay, so this has two aspects to it. One is the aspect of El Nino, La Nina. So El Nino and La Nina has existed for more than 3,000 years. The very initial records of El Nino have existed in South American continent for more than 2,500 years, and it is a natural system. So even if humans did not exist on the planet, if we had the structure of the continental setup the way we have today, El Nino would have existed. In fact, there are also some paleo studies which say that there used to be an El Nino like system even when Indo-Pacific Ocean was one single ocean. So it's not for us or any other country to take responsibility for El Nino. It's a natural system. What we can take responsibility for is how everything is changing. And here comes the debate which has been ongoing for almost 50 years now. So the kind of or the scale of climate change that we are experiencing now primarily started with the industrial revolution, and the countries of the global north have consumed a lot, used a lot of resources, used fossil fuels very liberally, and now it has come to a point where countries of the global south, like India, several countries of the South Asian continent, African countries, are now being told that, oh, the climate is changing, and now you have to not use your carbon footprint as much or not use as many fossil fuels. So while the point is partially correct that yes, there is a responsibility which has to be taken by the global north, which, even though they, in principle, some of them may agree that yes, the responsibility lies with the global north, but how do you take responsibility? It there is also has to be some action which is sort of telling them that yes, this is a responsibility we took, and look, we are doing these as reparations. So that is something which is still not happened. Now as far as India is concerned, we also have a lot of inequality in the country. There's a huge amount of socio-economic inequality which is plaguing our country. While we may not be entirely responsible for climate change, that does not mean that we should be living exactly the way the global north has, or we should be getting involved in activities which the global north has in the past, because that has basically just led to disasters. So one way to look at it is, uh, yes, we are not responsible, but does that mean we want to be responsible for further destruction? And also, if you look at most of the countries in the global south, India is one of the relatively more developed ones. If you compare it to countries like Sri Lanka, Pakistan, Bangladesh, Bhutan, all of these countries are not even consuming the same amount of resources as India alone is having. So when it comes to taking responsibility, if we are holding someone else responsible, we also have to hold ourselves responsible and accountable for what will go wrong if we choose to consume resources uh, out of our, beyond what should be done. So yes, it's a slightly delicate matter, but it's a question of what kind of world do you want to leave for the future generations. Do you think that as an adult you will be able to look maybe your grandchildren or your great grandchildren in the eye and say that, oh, we consumed so many resources because the global north was responsible and we were not responsible for the this thing, but now there are hardly any resources available for your generations? Do you want to be in that place? And as far as role is concerned, yes, there is a lot of geopolitical issues, there are a lot of infrastructural development issues, but the question that I tend to ask myself is, during any argument is, who is it that we are fighting for? Are we fighting for luxury, or are we fighting for a livable planet for all human beings and for flora and fauna? Because none of the animals, none of the trees have done anything to uh, mess with the climate. It is only human beings. In fact, the IPCC, which is one of the institutes which never gives out a political statement, actually made a statement in AR6 that the current change that we are seeing in the climate is primarily driven by human activities. So it's a very significant change from what their usual reports are. So yeah, I mean that's how I look at it.
So,
I hope that answers your
Aditi,
question.
Aditi, I have a question on those maps. You,
Yeah,
you were showing that active and break,
yeah, I can
right?
share it again. Huh?
Yeah. So I saw that too, like central India was there and the
Yeah,
northeast part was there. But
yeah.
then there is lot of white region in both of these. So what happens there then?
Yeah, so this is basically plotted from data, and they have plotted more than significant. So see, you can see this 3 plus 3 and minus 3.
Yeah.
So anything which is below plus 3 and minus 3 is given as a white color. That does not mean that it doesn't have rainfall or it doesn't have data. It is just that it is not significant enough to be pointed out as a pattern.
So they never have active spell or they have
No,
but
no, they
not
have active
plotted
spells.
here.
They have active spells and break spells, just not very high enough. And one more thing is that this is what is called as a rainfall anomaly. Anomaly means, okay, this I'll explain in Marathi. या वर्षीचा पाऊस आहे, ठीक आहे, जून महिन्याचा पाऊस आहे, आणि आपल्याकडे गेले 50 वर्षाचा जून महिन्याचा रेकॉर्ड आहे. सो हा ह्या वर्षीचा जो जूनचा पाऊस आहे तो बाकीच्या वर्षांपेक्षा कसा वेगळा होता, किंवा जनरली जसा जूनचा पाऊस असतो तो कसा वेगळा होता, त्याच्यासाठी हा अनॉमली म्हणून कम्प्युट केला जातो, की ह्या वर्षीचा जूनचा पाऊस मायनस 50 वर्षाचा जूनचा पाऊस जो असतो तो सबट्रॅक्ट केल्यावरती जो राहतो, that will be what is different in this year's June rainfall compared to the other 50 years of June rainfall. And that is a relatively small value. So if you plot the actual rainfall, it will not be 12 mm per day. It will be significantly higher. So this is the anomaly is basically very small. So to bring out this pattern, they have simply not given it a different color. But all parts of the country go through an active spell, break spell. Just the amount of rainfall that you see is different.
Okay, got it, got it. Thank you. Anybody else has any questions? एक तर तुम्ही अनम्यूट करून विचारू शकता किंवा तुम्हाला टाईप करायचं असेल तर टाईप करू शकता.
थँक्यू दामिनी.
ओके. जर कोणाला क्वेश्चन्स नसतील तर आपण थांबूया. मला असं वाटतं की खूपच इन्साइटफुल होतं. वी रिअली गॉट टू लर्न अ लॉट. And you understand how complex the whole system is, so it's very difficult to predict. Of course, as you say, that there is an impact of climate change, but it's not the only thing, and there are so many other things. So it's quite insightful. So thank you for coming. And maybe we can what happened this week is that there was a short notice.
Yes.
And also we had some event 2 days back, so we didn't get much of participation, but maybe next time we'll plan it better and we can come up with another topic. But thank you so much. And those who couldn't attend this, if your friends and people in your network, if they couldn't make it because it's a weekday, you can tell them that this will be uploaded on our YouTube channel. You can go to YouTube and look for Pune River Revival. Yes, the recording will be there. It will be uploaded this week. And if you have missed any of our previous webinars, they are all there on our channel. There is a playlist called as Wednesday Webinar, and you can look up and you can learn a lot there. I mean, that's how we all are learning. So thanks again, Aditi.
Thank you.
And thank you everybody for attending. Yeah, sure.
I just wanted to say one thing, that this half an hour is literally the tip of a needle that I have talked about monsoon. There's a huge amount of work in every aspect, and of course, I'm not an expert in all of them, but it was literally the tip of a needle. So, yeah, I mean, there's a lot to talk about. I hope you find more people. I would be happy to help you all locate them.
Sure, we can do that. We can plan some other time. And thank you everybody for participating. Have a good night and see you next Wednesday.
Thank you so much, Simi. Thank you.